Hi everyone, welcome to Chapter 3, Introduction to the Atmosphere. So we are going to spend the next chapter talking about our atmosphere, which is this wonderful thing that allows us to live quite happily on this planet. We're going to talk about the makeup of the atmosphere, how it affects us, how we have affected it, and then we're going to wrap up this chapter with a discussion of weather and climate. So what is the atmosphere? The atmosphere is the thin layer of gases that surround the Earth. Not only do they provide us with oxygen, but they also control temperature, and they make the planet a nice habitable place for us. So again, provides oxygen, which of course we need to live. It absorbs radiation and moderates the climate, right? So as solar radiation comes in from the sun, and we'll spend a lot of time in future chapters talking about solar radiation, but as solar radiation comes in from the sun, the atmosphere holds on to some of that, makes the planet not get too cold when we're away from the sun, and it also reflects some of it so it doesn't get too hot here when we are facing the sun. It also transports and recycles water and nutrients. In Chapter 9, we're going to talk about the hydrosphere, but a lot of water recycling on the planet happens in the atmosphere. Water evaporates up into the atmosphere, comes back down as precipitation, and often gets kind of cleaned out in the process. So throughout the history of the Earth, the atmosphere has changed through a variety of natural phenomena. And human activity is now changing the atmosphere. Probably the way that you often hear about most, especially in the news these days, is through that of climate change. We're going to spend an entire chapter talking about climate and global climate change. But at the end of this lecture, part 2 of this lecture, we are going to talk about what climate is in the first place and what weather is and what's the difference. So there are 5 main layers to the atmosphere. This is going to get a little listy for a while, but you need to know the layers of the atmosphere. They differ in temperature, density, and composition. The first and the lowest layer is the troposphere, which is where we spend the vast majority of our time. It goes from 0 to 11 kilometers, or about 7 miles above sea level. Don't be concerned about these numbers. They're good to give you an understanding, but no one is going to quiz you on how high the troposphere goes. They are responsible for weather, right? So all of our weather happens within the troposphere. It is the layer of the atmosphere that we interact the most with. And if you are of an age that I am, you might remember The Jetsons, which was a popular cartoon when I was a kid by Hanna-Barbera. The Jetsons lived above the troposphere, so they always had nice weather. They didn't have to deal with any of the weather. In reality, that wouldn't work because they wouldn't have very much oxygen and it would be pretty darn cold. But it was a cartoon, so it worked. So the air gets colder with altitude in this layer, and this is going to change. If you look at this drawing over here on the right, you're going to see this is temperature, and the temperature is going to change as we go through the atmosphere. So right now with the troposphere, as you go up, it gets colder. You're farther away from the warmth of the surface of the planet, which is pretty intuitive, right? As you generally go higher in elevation now, if you think about just driving up in elevation, it's going to get cooler. The tropopause, which is this layer right here, which is usually signified by clouds, not always, but is the boundary between the troposphere and the stratosphere and prevents their air from mixing together. The next layer is the stratosphere, not just something to visit in Las Vegas. It goes from 7 to 31 miles above sea level. This, for the most of us, this is the only other level of the atmosphere that we interact with, and this is when we fly in an airplane, you wind up in the the stratosphere sometimes, when you go above the clouds. It is drier and dense. It has less vertical mixing, so things tend to kind of be more layered and stay where they are, less moisture in the air. The temperature is then going to increase with altitude because you're not going to have as much protection from solar radiation, so that temperature is going to actually increase. although it would still feel colder because there's not a lot of molecules up there to hang on to that heat. In the stratosphere, we have the ozone layer, which is very, very important. The ozone layer for us blocks a lot of harmful UV radiation. It is another thing that allows us to kind of have a happy existence here on planet Earth. And the stratopause, like the tropopause, is the boundary that limits mixing between the stratosphere and the mesosphere, which is the next layer. The mesosphere, right, goes from 31 to 50 miles above sea level, or 50 to about 80 kilometers. There's extraordinarily low pressure in the mesosphere. It gets colder with altitude because there's almost nothing to hang on to. The mesopause is the boundary that limits mixing between the mesosphere and the thermosphere. So also, it's where meteors burn up, right? If you happen to see a shooting star, it's actually a meteor coming into planet Earth's atmosphere, and that's where it's going to get burnt up. The thermosphere and the exosphere, and depending on the textbook that you use, they might not even talk about the exosphere, you might just end with the thermosphere, but those are the kind of most upper layers of the atmosphere. They go from about 50 miles up to space. There's no definite end or boundaries. Temperature technically is increasing, but it would feel very cold to us again because there's no really atmosphere in there to hang on to anything. There's very, very little molecules. And but the radiation, as you have kind of left the comfiness of the lower levels of the atmosphere, the radiation would be quite strong. This is where you see the auroras, and which are the northern lights. There's also southern lights, but less people get to see those because we have more land in the northern hemisphere. There'll be a short video for you to watch as part of this module, looking at the auroras and what they are and how they work. They're very, very interesting. Next, we're going to talk about air pressure. So air pressure is the weight of the air. We don't feel the weight of the air, generally speaking, at sea level. We are used to it, but there is the weight of all of the air above us is pushing down on our body. It's being held in by the gravity of the planet, and it's putting pressure on us. Air pressure decreases with height at a non-constant rate, but as you go up, there's less and less air pressure. So again, when you go up into that airplane, they give you that talk about if there's a decrease in cabin pressure, that mask is going to come down, and that's because there's less air pressure up there, right? So there is just less air up there. Low levels are compressed by the air above, so the surface pressure is much higher than it is the further you go up into the atmosphere. 90% of the atmosphere, or 90% of its weight, is in the lowest about 10 miles. So if you're going to think about just the mass and the weight of the air, most of it is being held closely to the planet's surface. Right? Gravity is stronger near the surface than it is the higher you go in altitude. When we look at the size and composition of the atmosphere, overall. So the atmosphere uniquely surrounds the Earth, kind of like a nice little warm blanket, again, held down by Earth's gravity. And more than 50% of the total mass is below 6 kilometers, right? So if you go, there's a little illustration of Mount McKinley, which is at 20,000 feet, right? The vast majority of that atmospheric mass is below the elevation of the peak of Mount McKinley. The composition of the atmosphere, people might think that it's mostly oxygen, and it's not. It's actually mostly nitrogen. There are two primary gases that are permanent, that stay kind of at their ratios, and those are oxygen and nitrogen. And then there's a bunch of variable gases that include water vapor, carbon dioxide, ozone, and some other ones that kind of vary depending on where you are. But these permanent gases, that oxygen and that nitrogen, and to some extent that carbon dioxide, which is a variable, actually not a permanent, but they make over 95% of the total atmosphere. So when we talk about global climate change and us adding more greenhouse gases in, they're actually a very small percentage of our atmosphere, but they can have a really, really large effect. We also have particulate matter in the atmosphere. These are non-gaseous particles that exist in the atmosphere, often what we think of as pollution. There are many human-induced and natural types of pollution. Not necessarily pollution, but particulate matter. Many are hygroscopic. And what I mean by hygroscopic is that they will attach to water particles, water molecules in the air. So that you can actually, the concept of acid rain is a hygroscopic particulate matter that is held onto a water molecule and then rains down somewhere else. Some reflect and some absorb some light. So if we look at a satellite image of a dust storm coming out of the Sahara, there's a bunch of really easy to see particulate matter, this very fine dust that has been kicked up into our atmosphere. I am not going to pretend to pronounce the name of this volcano in Iceland, but in 2010, this volcano erupted, throwing a ton of particulate matter into the atmosphere that disrupted air travel all over the world. As this cloud of particulate matter traveled around, air traffic routes had to be rerouted for months afterwards. We also have human-induced change to the ozone layer. We used to release a lot of something called chlorofluorocarbons, especially in the late 70s, early 80s, and that was eating a hole in our ozone layer, which again, that ozone layer protects us from a lot of really bad UV radiation, and the world got together and made the Montreal Protocol and stopped releasing those chlorofluorocarbons. So international treaties do work sometimes, but you can see that hole in the ozone layer, which is over the poles, but from 1979 to 2012, those chlorofluorocarbons take a really long time to come out of the atmosphere. They have a really high residence time, it's called. So again, when talking about pollution, right, air pollutants are gases and particulate material that are added to the atmosphere. Those are the pollutants, the things that we are adding to the atmosphere. They can affect climate or harm people or other organisms. Pollution is the release of those pollutants. And this has recently decreased due to government policy and improved technologies in developed countries. Air pollution in the US used to be quite bad. But thanks to the Clean Air Act and the EPA, our air quality is dramatically better than it used to be. Developing countries and urban areas still have significant problems with air pollution, especially urban areas in developing countries. California has some of the highest clean air standards in the world, and so we kind of set the curve a little bit in the United States. We have very strict emission standards on our cars. But in a lot of other places in the world, that is not necessarily the case. Greenhouse gas emissions, which again, we'll talk about more when we deal with global climate and global climate change, may be our worst pollution problem to date. So again, pollutants, there are primary pollutants, which are those directly released into the atmosphere, and those include particulates, carbon monoxide, nitrogen compounds, sulfur compounds. And then there are secondary pollutants. These are reactions that happen in the atmosphere due to something that was released in the atmosphere. So photochemical smog is one of them. Smog is actually a reaction to something being put into the atmosphere. And again, ozone, right? We can have problems with ozone pollution. And so here is a little picture of Los Angeles, part of Los Angeles, an elevation model. And so down here, this is where the city of LA is, and here are the mountains that are directly to the east of it. And so what happens when LA, the reason that some of the smog is so bad in LA, although it's gotten much, much better, is that cars down here release a bunch of pollutants, and then this air is cooler. Then we have warm air that comes from the desert over these mountains and acts like a cap, right? Warm air is lighter than cold air. That cooler air stays down there and kind of leaves that smog there. And so sometimes the smog in LA is much worse than others, and it kind of depends on whether or not it's allowed to dissipate. I'm from the Northeast. We don't have that problem there. In New York City, plenty of cars and traffic, but we don't have this geographic condition that kind of creates this cap on our smog. And so again, here's a picture of kind of what it looks like on a smoggy day, this general kind of brown haziness to the air. And we can see how dramatic that effect is too. Back in 2012, we had Carmageddon when the Interstate 405 was closed for a day, and people were calling it Carmageddon before it happened because they pictured massive traffic problems. But what happened instead is everybody in LA just decided to stay home. And so there was actually dramatically less traffic than on any other given day in LA. And that day, they could measure dramatic and instantaneous air quality improvements. But again, air pollution has kind of been historically bad in a lot of places. In 1952, you can have these events, right? The air pollution in London used to be quite severe. And they had a smog that came in, which is sometimes referred to as the Great Smog or the Great Fog, a specific weather event that the air could not move away from London, and it was a 5-day event, and the air pollution actually killed 4,000 people. So this air pollution can be quite serious, especially living in a city. A lot of people can develop asthma from these types of pollutants, and it can also aggravate these asthma conditions once you've been diagnosed with asthma. And so you can actually check what the air quality looks like in your area on the internet. And so this is from a little while ago, but you can see this day we had moderate air conditions over San Diego. Typically, San Diego, LA are moderate. Sometimes they will be more to the unhealthy, and people will put out warnings that basically if you are asthmatic or have some type of other breathing problems, you should probably try to stay indoors. So next what you're going to do is you're going to watch a short video on the Salton Sea state recreation there and some of the air pollution problems that are occurring around the Salton Sea and why they are occurring. And then you're going to complete exercise 4 before you move on to the second half of the chapter 3 lecture, which will deal with weather and climate.